Hi guys, welcome to Lesson 10.3, Operations with Radical Expressions. Our objectives for today are that I can simplify sums and differences of radical expressions, and that I can simplify products and quotients of radical expressions. So some vocabulary words, like radicals, are radicals that have the same radicand. Remember, that was what was underneath the radical symbol. Okay? The conjugate is the sum and difference of the same two terms. The product of a conjugate is a difference of two squares.
Ooh, a difference of two squares. Chapter 8 coming up.
Yay. Essential understanding. You can use properties of real numbers to perform operations with radical expressions. So problem number 1, we're starting off with combining like radicals. We see that we have the same radicand. They're both square root of 2. So now we just have to subtract the coefficients. 7 minus 8 is negative 1 times the square root of 2, or you could write it as negative square root of 2. Both are acceptable. Letter B, we have square root of 5 and square root of 5, same radicand. So we are going to add our two coefficients. So 5 plus 2 is 7, square root of 5. Letter C, we have square root of 7, square root of 7. So we're just going to add our coefficients. 3 plus 11 is 14, square root of 7. Okay, I want you guys to try D, E, and F on your own, and then we'll go over them. So letter D, we have square root of 10, square root of 10. So we just do 9 minus 5. And that gives us 4 square root of 10. Letter E, square root of 6 in both terms. So it's 5 minus 3, which is 2, square root of 6. Letter F, square root of 11 in both terms. 10 minus 3 is 7, square root of 11. Pretty simple, pretty straightforward, right?
Right.
So now we're going to twist it up a little bit and go down to simplifying to combine like radicals. So we're going to need to simplify first, and then we'll be able to combine them. So if we see our radicands, we have a 7 and a 28, but I can reduce 28. And I can rewrite that as 2 times the square root of 4 and the square root of 7. So the square root of 4 is 2, and we still have the square root of 7. Now don't forget there's a 2 out in front of that already, so it's 2 times square root of 7. So when we rewrite,
Bringing this straight down.
we have 4 square root of 7. 2 times 2 is 4 square root of 7. 4 plus 4 is 8 square root of 7. Okay. Letter B, we have a 32 and we have an 18. So we're going to have to simplify both of these radicals. So we've got 5 times the square root. Well, 32 can be broken into 16 and 2. So we want to try to find perfect squares. So we got square root of 16 and square root of 2. Minus 4 times 18 can be broken up into 9 and 2. So it's square root of 9 and square root of 2. Simplify the square roots that we have. Square root of 16 is 4. So we have 5 times 4, square root of 2. Minus 4 times square root of 9 is 3, square root of 2. 5 times 4 is 20. 4 times 3 is 18. Sorry, 12. 20 minus 12 is 8, square root of 2.
You might want to pause the video and watch that again.
Okay. Letter D, we have 7 square root of 6 minus 2 square root of 54. So we're going to have to break 54 into its factors. Well, I know 54 is 9 times 6. So we've got 7 square root of 6 minus 2 times square root of 9, square root of 6. Square root of 9 is 3. So we have 7 root 6 minus 6 root 6. And we get square root of 6. Okay. All right. Letter E. 3 times the square root of 7 minus 4 times the square root of 63. Square root of 63 is broken into square root of 9 and square root of 3.
Sorry.
9 and square root of 7. Square root of 9 is 3. Mrs. Urzo just got a little bit ahead of herself on that. So we've got 4 times 3 times the square root of 7. 3 root 7 minus 12 root 7 gives us negative 9 square root of 7.
These are fun.
Yep. All right.
These, not so much. No, I'm just kidding.
Problem 3, multiplying radical expressions. Yay! All right. So, first thing we need to do for letter A is the distributive property. Square root of 2 times the square root of 6 is going to be the square root of 12. And the square root of 2 times 5 is 5 square root of 2. Now, we always want to make sure that our radicals are as reduced as they can be. And the square root of 12, I know, has a perfect square inside of it because that is 4 times 3. So we got square root of 3 times square root of 4 plus 5 root 2. Square root of 4 is 2. So we've got 2 root 3 plus 5 root 2. Now, do we have any like radicands? No. So we are just going to leave it there. That is your simplified form. Letter B, we're doing FOIL with radicals. Yay! So it's, just remember, square root of 11 minus 2, the quantity squared. That whole means we're foiling. So if it helps you to draw in your extra term, go ahead. So we've got the square root of 11 times square root of 11, which is just 11. Square root of 11 times negative 2, which is minus 2 root 11. Negative 2 times square root of 11 is minus 2 root 11. And negative 2 times negative 2 is positive 4. So now let's combine like terms. We have 11 minus 4 radical 11 plus 4. We still have a couple like terms there, that 11 and 4 being added together. Remember, the sign in front of the number is attached to the number, so it is 11 plus 4, which gives us 15, minus the square root of 4, or 4 times the square root of 11. And that's our simplified form. Letter C. Ooh, Mr. Bowling got mean on this one.
Jeez.
So the square root of 6 times 4 square root of 3 is going to be 4 times the square root of 18. Outer, we've got the square root of 6 times 3 square root of 6. So that's going to be plus 3 root 36. Then we've got negative 2 root 3 times 4 root 3. Multiply the coefficients, so that's minus 8 square root of 9, multiplying. And then our last term, negative 2 root 3 times 3 root 6. So negative 2 times 3 is minus 6. And we have square root of 18. So before we try to simplify anything, I want to combine any like terms that I have. And what I see is I have a 4 square root of 18 minus 6 square root of 18. So let's combine that one first. Is that what I did there? That is what I did there. So we have negative 2 square root of 18 minus, or sorry, plus, and I'm going to do you want to simplify right away in this step?
No.
No? Okay. 3 times square root of 36 minus 8 square root of 9. Now we're going to simplify our radicals that we have there. So square root of 18 is going to be 2 times 9. So square root of 9, square root of 2. And then we have the rest of it there. Square root of 36, which is 6 times 6.
Which is just 6.
Yeah. Minus 8 times 3.
Ugh. Okay, so this is a 3. So this is negative 6 root 2 plus 18 minus 24. Clean that up and you finally get negative 6 root 2
minus 6.
No. You have a minus 42. You had this as a negative.
Did I make a mistake with negatives? Yeah, I think I made a mistake with the negative sign.
Okay.
So, negative 6 root 2 minus 6. That's your final answer. All right, letter D.
Again, you might want to watch this a couple of times.
D, E, and F, try them on your own, and then we'll go over them. Letter D, square root of 5 times square root of 3 is square root of 15, plus 4 square root of 5. That's your simplified form. Letter E, again, it'll help if you draw in your second binomial of square root of 6 plus 5. So square root 6, square root 6, that's positive 6. And plus 5 root 6 plus 5 root 6 plus 25. Combine like terms, we've got 31 plus 10 square root of 6. All right, and letter F, another fun one. F is for fun. All right, so we've got 2 times 5 is 10. Square root of 6. 2 radical 3 times square root of 6 is 2 times the square root of 18. 4 times 5 is 20 radical 2. And 4 times the square root of 6 is 4 root 6. Now, I see that I can combine some like terms. So 10 root 6 plus 4 root 6 is 14 root 6. Plus 2 times the square root of 18. We can break 18 up into the square root of 2 and square root of 9. So it will be 2 times 3, which is 6, square root of 2, plus 20 square root 2. And now we can combine like terms there with the 2 square roots of 2. And we get 14 square root of 6 plus 26 square root of 2.
Wow, it makes me feel like I'm doing algebra now.
Yay, algebra! All right, so problem 4, rationalizing a denominator using conjugates. So remember, the conjugate we said was pairs of sums and differences of radicals. Notice, we can't just multiply by one radical in the denominator to eliminate both of them. So we're going to actually essentially use FOIL and that perfect squares theorem to do our work for us. So the opposite of, or the conjugate for square root of 10 plus square root of 5 is the square root of 10 minus the square root of 5. Okay, so we just flip the sign and we multiply by that on the numerator as well. So we've got negative 3 square root of 10 plus 3 square root of 5. Denominator, when we do our FOIL, square root of 10 times square root of 10 is 10. Square root of 10 times the negative square root of 5 is negative minus square root of 50. Plus square root of 50 minus 5. Okay. And we can see how this works now because we have minus 50 plus square root of 50. Those cancel out. And we're left with 10 minus 5, which is just 5. So we have negative 3 square root of 10 plus 3 square root of 5 over 5 as your final form. Okay. Letter B, we're multiplying by square root of 3 minus square root of 11, because that would be the opposite of, or the conjugate to square root of 3 plus square root of 11. All right, so we get 8 root 3 minus 8 root 11. Over 3 minus square root of 33 plus square root of 33. I just didn't show that step. Minus 11. So we have 8 root 3 minus 8 root 11 over, the middle section cancels out, 3 minus 11 is negative 8. Don't forget it was a negative 8 in the denominator. So we get negative root 3 plus root 11. So you should always be looking to see if there are factors that you can cancel out.
Are you having fun yet? Because I know I am.
Mrs. Urso doesn't like this. For some reason I do. All right. Yeah, I know, I'm weird. You're all thinking it. Square root of 21 minus square root of 15. The conjugate of that would be the square root of 21 plus the square root of 15. So when we multiply that out, we get the square root of, well, I just broke it into my factors right away. Square root of 3 times 3 times 7. I broke it into my factors, just starting off, like I knew I had square root of 3, and that's 3 times 7.
Okay, well, don't mess with us right now.
Okay, fine. So square root of 3 times square root of 21, plus the square root of 3 times the square root of 15, over 21 minus 15. So you can see how we could just shortcut that FOIL process. We don't need to deal with that.
Okay, so this is 3 times 7.
Yep. So we've got square root of 3, square root of 3, so that's a pair that we can bring out. So it's 3 root 7 for the first term. And that is 3 and 5, so we've got 3 root 5. So we've got 3 square root of 7 plus 3 square root of 5.
Hey.
Over 6. Oh, look, there's some common factors there. So we've got the square root of 7 plus the square root of 5 over 2. All right, so you might have questions on this. I would highly recommend that you write them down. I would highly recommend you write down where you're getting tripped up on these problems because they do require just a lot of practice. Okay, so make sure you're filling out your level of understanding and make sure you're writing down that summary and identify those places where you are struggling so that we can help you. All right, see you in class.